as having 9 vital signs, called planetary boundaries. These natural guardrails keep our environment stable, but human activity has pushed past these limits. Today, 7 of the 9 boundaries have been transgressed, placing our planet in a high-risk danger zone. This chart tracks the climate boundary. Panel C shows the global surface temperature has reached 1.1 degrees Celsius above pre-industrial levels, with the sharpest increase occurring in just the last few decades. To find the rate of warming comparable to what we are seeing today, you would have to look back more than 10,000 years. Hearing 1.1 degrees might sound like a minor fluctuation in daily weather. So where is all that world-altering energy actually going? A 1-degree shift across the entire planetary surface adds a vast amount of thermal energy to our environment, straining the foundation of our life support system. Most of that extra energy doesn't stay in the atmosphere. 90% of it is absorbed directly into the ocean, where heat content reached record highs in 2024. Injecting this much thermal energy into the seas causes the water to physically expand. That warm, swelling water melts the ice sheets from underneath. Satellite data gives us the precise scale of the melting. Greenland is shedding 279 billion tons of ice every single year, while Antarctica is losing another 148 billion tons. This rapid continent-scale loss of ice is now the primary driver of global sea level rise. But beyond the obvious threat of flooding coastlines, what happens to the Earth's internal thermostat when massive, continent-sized white ice sheets simply disappear? The ocean has acted as a giant planetary battery, storing our excess heat. Now, that stored energy is destroying the very ice that helps regulate our climate. To understand the consequences, we have to look at the albedo effect. Normally, bright white ice acts as a mirror, reflecting incoming solar energy back into space. As that white ice vanishes, dark ocean water replaces it. This darker surface absorbs the sun's heat instead of reflecting it, creating a loop where the planet accelerates its own warming. If the collapse of this ice system accelerates warming on its own, could it trigger other planetary systems to collapse in a domino effect? Scientists warn that this is exactly what occurs in a cascading tipping point. For example, the heat gain in the Arctic causes ancient permafrost to rapidly thaw, exposing soil that has been frozen for millennia. That thawing Earth holds roughly twice as much carbon as the entire atmosphere. As it melts, it releases massive amounts of trapped methane, a greenhouse gas far more potent than CO2, driving global temperatures even higher. This secondary temperature spike travels across the globe, contributing to the dieback of the Amazon rainforest and the mass death of tropical coral reefs, which bleach and crumble as the water warms. If these natural systems are locked in an accelerating, self-sustaining cascade, what pushed the first domino? Crossing just one physical threshold has the potential to shift Earth into an irreversible hothouse state, moving control of the climate entirely out of human hands. Air bubbles trapped in ancient ice cores show atmospheric CO2 is at its highest level in at least 2 million years, with the sharpest increase beginning exactly as modern industry began. Because no natural orbital cycle moves this fast, 99% of scientists agree the first domino is human activity. These cooling towers represent the primary drivers of the crisis, the combustion of fossil fuels and the massive land use changes that have occurred since the Industrial Revolution. Because human activity is the root cause pushing these dominoes, human action is the only mechanism left that can stop them. The IPCC has identified a critical boundary, limiting warming to 1.5 degrees Celsius instead of 2.0. That half degree is the difference between relative stability and triggering the most dangerous cascading tipping points. Protecting that margin preserves global food security, reduces heat-related mortality, and prevents the most severe global economic losses projected for the end of the century. We don't need to wait for experimental breakthroughs. Solutions like solar energy, wind power, and the electrification of our cities are technically viable and cost-effective today. But the window of opportunity is rapidly closing. We have to transition to net zero emissions immediately to break the loop. The planetary boundaries are breached and the cascade has already begun. But aggressive, immediate systemic action can still pull Earth back from the edge and secure a livable future for all.